In 6b, we're looking at the function. Now, we're going to focus on the transformations and work on the function notation after. But we're going to break it down into horizontal and vertical. And again, I'm going to start with the vertical because the vertical tends to be the easier one because we don't have to undo anything. So the vertical transformation is an expansion by 3 first and then down 1. So I'm going to take my y's, I'm going to times by 3 and then subtract 1. Okay, and this represents my change in y. Okay, so I'm going to represent this as my new y coordinates is going to be transformed in that way. So writing the function notation then, we know that the function notation is going to be on the y transformations is all on the outside. So I need to then multiply everything by 3 and then subtract 1. Now that's going to have an effect on what's already in this equation. So I'll do that after. So I'm just going to do the function notation first. So I'm going to do the x transformations, and my x transformations in what I do and what I actually put into the notation are complete opposite. So my coordinates are going to be, I'm going to first of all flip it and compress by 1/2. So I'm going to flip and compress by 1/2. And then at the end, go shift to the right 2. Now what I've written here cannot go into the brackets yet. Although this is exactly what happened, I need to reverse this before I put it into my notation. So reversing it means I'm going to undo this calculation. So I'm going to undo the +2 first, and I'm going to undo the divide by -2 by timesing by -2. And that just happens to get me back to my old x, which is my notational form. Now again, I don't need to keep track of old and new. I just need to make sure I undo when I go from one to the other. So notation to description or description to notation is the same process. We're undoing. So I'm going to write this in my notation like that. There's my function notation, and that is the transformations for x and y written out. Now I now have to account for the fact that this function was my original function. I have to make sure I understand which part of it is inside and outside. So when I write my new y, I have my function here. I have my inside x, and I have the outside of my x. Okay, so I'm going to start with the outside. So everything that's bracketed in the square brackets represents the f of x. So on the outside, I'm going to times 3 minus 1. And then I can plug in my inside. That's notation still. So it's going to be -2 x minus 2 brackets like that. Okay, I'm just going to get rid of that notation. We don't need that in there. So I can leave it like that. So that's one of my solutions here. So if I can see that that's one of my solutions here. I can also get rid of these brackets and rewrite this equation. Now this is perfectly fine, but if I want to get rid of this, oops, I'm missing something here. There's a -2 here, and then brackets, and then -1. Okay, so you can see that there's that -2 that I missed in the first solution. So now if I want to get rid of these brackets, I can multiply the brackets by 3. So I multiply by 3, I end up with 3 on top here. The denominator doesn't change. This -2 becomes -6, and I have an extra -1 here, so I can combine those like terms. I get 3 over -2 x minus 2, and this is all squared, plus 1, and then -7, and that gives me the other solution that's shown in the answer key here.